Hello everyone, we are Team Icecubes from Tyagarajar College of Engineering. For this hackathon, we chose problem statement 5, AI-driven grid stabilization and autonomous control system. We selected this problem because modern power grids are facing increasing challenges in maintaining a balance between energy supply and demand, especially with the growing use of renewable energy sources and electric vehicles. Our solution focuses on using AI-based prediction and autonomous decision support to detect grid imbalance early and recommend actions to maintain grid stability. Existing system and limitations. Currently, grid monitoring systems such as SCADA systems mainly work in a reactive way. They detect problems only after issues like voltage drops or overloads occur. However, they do not predict grid imbalance in advance or suggest corrective actions automatically. This limitation inspired us to build an AI-driven predictive system. To address this problem, we designed an AI-driven grid stabilization system. Our system uses historical energy datasets to predict electricity supply and demand. The workflow starts with collecting historical data from solar generation, wind generation, base electricity demand, and EV charging demand. Using these datasets, we train machine learning models to predict real-time supply and demand values. Then the system calculates the grid imbalance by comparing the supply and demand. If instability is detected, the system automatically recommends corrective actions to stabilize the grid. Two core features on our system. Our system mainly focuses on two core features. The first feature is prediction. Using historical energy data, our machine learning model predicts the real-time electricity supply and demand. The second feature is autonomous recommendation. When the system detects imbalance in the grid, it uses rule-based decision logic to recommend actions such as load balancing, power rerouting, or adjusting the EV charging. Model building process. Each dataset is first pre-processed and used to train separate prediction models. This allows us to estimate solar energy generation, wind energy generation, base electricity demand, and EV charging demand. After predicting these values individually, we combine them to calculate the total electricity supply and total demand. To build the prediction model, we use XGBoost regression, which is highly effective for structured datasets and provides accurate predictions. Now let's move to grid imbalance detection. Once we obtain the predicted supply and demand values, the system calculates the grid imbalance using the formula. Grid imbalance is equal to supply minus demand. If the demand exceeds supply or supply exceeds demand, the grid becomes unstable. Now let's move to the feature recommendation system. To handle this instability, our system includes an autonomous recommendation engine. It analyzes the imbalance and suggests actions such as adjusting EV charging load, redistributing power, or using stored energy. So in summary, our system uses AI-based prediction and autonomous decision support to help stabilize modern power grids and prevent failures before they occur. Thank you.